I'm Daniel Moore, and today we will be quickly discussing the difference between direct and parametric modeling. Now, why this is relevant to our discussion of how to use CAD is that different CAD programs focus on one or the other of these two modeling options. The first, direct modeling, requires an individual to go and define every single change. Even if they have to edit it, they have to go back and tweak everything for an edit when they're revising. Now, by comparison, parametric modeling, if you want to go back and make a revision to something that was done earlier, you just change that one little thing and you don't have to worry about how it affects everything else, because it remembers all the individual steps and carries the changes forward. So let's take, for example, a math problem. Let's say we have all these different lines of work, and we have this final boxed answer here. Now, it turns out that this boxed answer is incorrect. It's not what we want. Now, the comparison for direct modeling would be that to get the correct answer, we add, we subtract, we do something to this final answer here to get the correct answer. By contrast, what parametric modeling does is, in our math example, is if the original error that we made was way up here, what it does is it automatically accounts for how, if we fix this, how it affects this, affects this, affects this, and ultimately leads to the right answer. With parametric modeling, we can make an earlier revision, and it carries forward all the changes to affect the final. With direct modeling, we can only affect the final thing we have. We can't touch any of this with direct modeling, but we can with parametric modeling. There's history with parametric modeling. And so we'll go ahead and illustrate this on the computer as well.
As an example to help illustrate the difference between direct and parametric modeling, here we have a general shape that we can modify. For example, let's say that we wanted to thicken the walls of that inner extruded section, that section that's sticking down into the chamber. Say that we wanted to thicken those walls. Now for direct modeling, what we would do first off is we would create a sketch outline that we would then use to extrude up and thicken the walls. And so we can go ahead and do that. Do all the geometry and stuff, and then extrude that out into 3 dimensions and pull that up. But let's say, for example, we wanted to also increase the inner cut as well. That way, the whole thing is enlarged, including the inner area as well. We're not just thickening the walls of that cavity, we're making the cavity itself bigger, which requires us to make the walls bigger in the first place. So after making the walls thicker, we can then take out extra area by making a cut down into that cavity to enlarge it. So we've gone through a couple different steps of thickening the walls and cutting it, and that's modifying step by step the original geometry that we had. Now let's say, for example, that this is too time consuming and we want to do this a little bit faster. What we would instead use is more of a parametric modeling. we would go back and look at an earlier feature, an earlier geometry, cut, extrusion, or whatever that we had defined, and we would change what we did in the past. We would go back to an earlier step in our process and modify what we did. For example, here we had an initial rectangle that we did a cut into it. So here we can modify that by making that rectangle a bigger rectangle and using that to do our earlier cut. And fixing a couple errors that might pop up and defining what exactly we're using to cut with, what geometry we're using to cut into that larger prism that we have here. We can then carry forward that, and all of a sudden, all we did was change one thing. We changed the rectangle that we were using for that earlier cut, and we've changed the size of that intersection in that inner region of the overall model. Instead of going through several steps, we just did one step. And that's one of the beauties of parametric modeling when compared to direct modeling, is that if you have to go back and edit something later, which we will most definitely have to do in Design Build Fly or any other engineering project where we have to make revisions, you only have to usually go back and change one little thing. Change one dimension, and then you can carry forward all the changes that cascade down from that. You don't have to worry about, do all the dimensions agree in every aspect? Have I made all the numerous changes that have to be accounted for? You don't have to worry about that. You just have to make that initial change, and then carries forward and changes everything else that's needed to account for it.
So as we've seen, the primary difference between the two approaches to CAD is kind of the degrees of work required to make a change. Parametric modeling has a history, and you can make carried through the history revisions based off of a change earlier on. But with direct modeling, you can only affect what's at the very end of all that. You can't touch what happened before. And different programs, as I alluded to earlier, generally use one or the other approaches. One of the primary examples I can think of right now that uses direct modeling is AutoCAD. And AutoCAD is a great program, and it's really versatile, especially with all the other Autodesk programs such as Fusion 360 and stuff that you can use. But it was originally designed as a 2D software, and it now has a bunch of 3D tools. So if we go ahead and have a drawing here, and we want to make changes here or here, it's 2D. Pretty simple to make changes. So we don't necessarily have to worry about history. But it's not as advantageous when we have to worry about three-dimensional items and we have to make changes. Now, SolidWorks, Fusion 360, Inventor, and a bunch of others use parametric modeling instead. They were specifically created for working in 3 dimensions, which goes a lot smoother when you have some kind of history. So I hope this clarifies one of the great advantages of using SolidWorks and helps clarify this key component of the type of modeling that SolidWorks uses. So in the next video, what we'll do is we'll walk through some of the tools of SolidWorks and actually get into what the program has to offer us.